show you matrix chain multiplication. And I'll be really honest with you guys, matrix chain multiplication is really not very easy topic, and I have the code ready in a separate tab, and I may also need to refer to that code. And I have pulled up this page. You can see the link here is given here. I will put it in the description, and the theory portion of this is given here. I will not go into the theory, I will just go into the actual coding, because what I have seen is everyone knows how the theory works, but when it comes to implementing it in practical program, people hesitate, not able to do that. So in this video I will go to the practical coding of this matrix chain multiplication, and yeah, let's hope for the best. To begin with, I have written a few lines beforehand. Now, very easy actually. It is include stdio.h, conio.h, then limits.h. These are pretty standard stuff. You know this obviously. And then in the main function, I have initialized the array. This array contains the dimension of the matrices. Like the first matrix has dimension 1 into 2. I will write it here. First matrix has dimension 1 into 2. Second matrix has dimension 2 into 3. Third matrix has dimension 3 into 4. So this is how it is given in the array. This is the format. Then int size equal to size of array divided by size of arr 0, means this array's 0th element. What this will give is the length of the array. This is a very fine way to find out the length of the array. Instead of this, you can hard code it to 4. 4. But I will keep it this way, because this is a better way to find out the length of the array. Then print minimum number of multiplication is %d and the name of the function. So this is the function which we have to write, the matrix chain multiplication function. Okay, now let's try to write this function. Well, it's going to return some integer, as you can see here, %d. So we are going to give the return type of this function as int means integer. Then as you can see, it accepts an array, right? So in the parameter list, it will also accept an array. Let's say the array is p, because in the books and in the theory mostly they give it as p. So you can see pi minus 1, pk, pj. This is this array arr. They're talking about this array, so I'm naming it p as well. And size is of integer, obviously, no doubt with that. And now let's go to the theory. The theory says mij is okay. What is mij? Mij is the array which contains all the multiplication of length n, of length l, and l will be changing, and I will show you all this. This theory you can go through from any book, Corman, or from this site. This site is very good actually. You can go to theory there. I'll just go through the coding. So mij is equal to 0 if I is equal to j. So what does this mean? This means we need we need a loop who says it's going to change the I loop. So in I, we are also going to need j and l. What is this l? The l is this. Here you can see, let l equal to j minus I plus 1 denotes the length of the subchain being multiplied. So this is l. So we need l here, and I don't know if we need anything, we will look at it now. For I is equal to, okay, what is I equal to? I is equal to, it was given here somewhere. Okay, way to initialize this to 0, right? Okay, first way to make this matrix. So comma m n n I mean size, way to make the matrix, way to make a matrix of the size of the array. So this is the format. Now for I is equal to 1, I is less than n, I plus plus, what we have to do is m of I comma m of I means ith row ith column is equal to 0. Why? Because of this. As you can see, mij is equal to 0 if I is equal to j. So we are doing this. I is equal to 1 to n I plus plus mi of I means the diagonal, actually it is initialized to 0. So this is done, this first part is done. Now for the second part, okay, for the second part it's a bit tricky, and let's explain this from this formula here. L is equal to j minus I plus 1, and if you read this properly, you can see that j takes the value of 2, 3 up to n. Okay, so the maximum value of j is n. So if we put n in place of j, the formula becomes L equal to n minus I plus 1. It becomes n minus I plus 1. L is equal to n minus I plus 1. Now if you rearrange, I is equal to n minus L plus 1. So this is the maximum value of I. Okay, so we'll put that in our code, actually in the for loop. Now what is the maximum value of what is the value of j? Value of j is, okay, L equal to j minus I plus 1. L equal to j minus I plus 1. Now what is j? J is equal to L plus I minus 1. So this is our I, this is our j, and this is the maximum value of I. We will need that. Let's remove this for the time being. Now for I is equal to not I, actually we need L now. For L is equal to 2, L is less than n minus L plus 1. Okay, when I'm talking about I, this is the maximum value of I mean this is the maximum value of L, means the maximum length of the, what's it called, subchain to be multiplied. L is the subchain to be multiplied, that's the maximum length, right? Maximum length is n minus I plus 1. Just hold on a second. If we observe the text here, it says then we build up by computing the subchains of length 2, 3 dot 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 up to n, means the length of the subchains are from 2 to n. So we have to write for L is equal to 2, L is less than n, from 2 to n, right? So it's less than n, L plus plus, and then we have to let's see, explain from here. Then it says like to find the length of the okay, for the length of subchain of size 2, we have to find the optimum value, right? So it is like now we have to run a for loop I, and the maximum value of I is given here, the maximum value of I, and this maximum value of j. So we'll need it. For I is equal to just hold on, for I is equal to, okay, for I is equal to 1 up to that thing. Okay, for I is equal to 1. Okay, why is it 1? Because we are going with the code that is given here, and it should have been 0, but we are taking a fake 0 comma 0, like we are wasting a space, and we are doing from 1 to n to make it more clear. Not we, I actually, it's only me doing. Okay, for I equal to 1, I is less than n minus l plus 1, then I plus plus. Okay, if you are a regular follower, you may notice that it's the first time I am actually a bit nervous doing this code, because matrix multiplication is not very easy, but it happens to come in our exams, and it's a very popular algorithm, so it's worth giving a try. uh, yeah, that's it. If you have any suggestion, you can obviously post them in the comments, and yeah, I will go through them. Now for I equal to 1 up to n minus l plus 1 I plus plus. Now we have to write the j loop here, because if you can see, I mean you can obviously see, it says minimum of I and j, minimum of I, we need I and j, right? We need that, and we need a key loop, actually not a j loop, we need a k loop. So we need a variable named k, and for k is equal to 1, k is less than j. Okay, k is equal to I, not 1. Why? Because as you can see, I is less than equal to k less than j, so I is equal, so k equal to I, k less than j, k plus plus. Actually, so everything is given the formula. You have to practice a bit and try to approach it, then you can obviously do it. Okay, so this is the value of k, it's a loop, and now we have to write the value of j. So j is equal to l plus I minus 1. It's given here, just paste it. Then we remove this, we don't need that anymore. So this value of j. Now again, if you observe this, it says minimum of whatever this is, this formula. It says minimum of this formula, means we have to assign some arbitrary value to m of I comma j, right? So for that I will write int max. What this will do is this will assign maximum possible integer value in m of I j. Now what we will do is I need a temporary value, so temp is equal to, this is in the formula, m of I k plus k plus 1 j. So m of I k plus m of excuse me, k plus 1 j plus p of I minus 1 pk pj. This is a formula, guys. I'm not making it up, this is a formula. P of I minus 1, then p of k, then p of j. So this is the formula, guys. To memorize this formula, I'm afraid this is how it works. Don't forget the multiplication sign. So temp is this. Now what we have to do is, if temp is less than m of I j, right? If temp is less than that, we will assign temp to m of I comma j is equal to temp. Like, this is what the algorithm says here, right? The algorithm clearly says minimum of this value, so whenever we find a value is less than this, we just assign it here. So this is it for the this is the matrix multiplication program, guys. This is it. This is return the value, return m of 1 and n minus 1, I guess. Now let's see how this program works. There will be some error, most probably. As you can see, it has to come. Anyways, let's see. N undeclared. Obviously n is undeclared, it has to be okay. Let's do something. Let's put n here. It makes more sense, right? Minimum number of multiplication is 18, and if you see this code, if you run this code, the minimum is again coming 18. I had that code opened up and I did not reference from it much, only 2 times actually. If you know the theory, this is how you can implement it. I know it's a bit complicated, it's not that easy, it's not that obvious, but it is possible. It is, I mean, there's an algorithm, so it has to be it has to yield a solution, right? So I suggest you practice this a bit, and I don't need to give the code because you can see the theory and you can do it. It's pretty easy. I gave it a try myself and suggest you guys to try it as well. So this is all for this video. Thank you and keep coding.